So on with some more on approximations and error, and this video is on absolute and percentage error, which comes up a fair bit in an IB exam. Whenever we measure a quantity, there is almost always a difference between our measurement and the actual value. This is called the error. So the size or magnitude of the error is called the absolute error, and it's always positive. And what makes it always positive is these straight lines either side of the equation. So absolute error equals the approximate minus the exact. And you see those two straight lines here? That means the absolute value, which means the answer is always positive, whether we do get a positive or a negative value. Error is often expressed as a percentage, and our percentage error equation is the approximate minus the exact, all divided by the exact. We take the positive value of that because we have the straight lines either side, the absolute value, and then we times it by 100. So just a quick example so you can see how it works. So you estimate a fence's length to be 70 metres, the true length is 78.3 metres. Find the absolute error. So the absolute error, if we look back at our formula, the absolute value of the approximate, which is 70, minus the exact, which is 78.3. When we do this, we'll have the absolute value, which is negative 8.3. Now, because we have the straight lines next to it, it means the error is just 8.3 metres. Our percentage error equals the approximate minus the exact, all divided by the exact, which is 78.3, and then we times by 100. And take the absolute value, you end up with 10.6%. Next example, bit of a longer one. So we've got Alan wants to lay carpet on his 4.2 metres by 5.1 metre lounge room floor. He estimates the area of the lounge room by rounding each measurement to the nearest metre. Find Alan's estimate to the lounge room area. Alan estimates by rounding each measurement to the nearest metre, so he's actually doing 4 metres and 5 metres, which means he's going to estimate the area as 4 times by 5, which is 20 metres squared. Part B. The carpet costs $39 per square metre. Find the cost of the carpet using Alan's estimate of the area. So nice and easy, the cost will be $39 per metre squared, and he's got 20 metres squared, so it's 39 times by 20, which will be $780. Part C wants us to find the actual area of Alan's lounge room. So the actual area will be the 4.2 multiplied by the 5.1, which is 21.42 metres squared. Part D, find the percentage error in Alan's estimation. As the percentage error equals the absolute value of the approximate, which was 20, minus the exact, which is 21.42, divided by the exact, and then we times that by 100. And when we do that, we get it is approximately 6.63%. Now, will Alan have enough carpet to cover his lounge room? How should he have rounded his measurements? So Alan has only 20 metres squared of carpet. So he doesn't have enough because the actual area is 21.42 metres squares. So in this situation, he should have rounded up to make sure he had enough carpet. And you just need to write that in some type of sentence. Okay, and one more example. So the side length of a square is measured as 22 centimetres, rounded to the nearest centimetre. Use this measurement to estimate the area of the square. So the area of a square is just side times side. So the area will equal 22 times by 22, which is 484 centimetres squared. So make sure you remember your units too. Part B, find the boundary values for the area of the square. So the boundary value is linked to the last video with where we have to look at the error with our plus or minus a half. So the first thing we need to do with this is work out the error in the measurement. So our original was 22 centimetres, but our actual side length could have been between 21.5 to 22.5. Now we can find out the different boundaries for the area. So the lower boundary of the area would be 21.5 times by 21.5, which is 462.25 centimetres squared. And the upper boundary would be 22.5 multiplied by 22.5, which gives us 506.25 centimetres squared. C, find the maximum percentage error in the estimate. So we now actually want to work out two percentage errors, one for the lower and one for the upper, and find out which is the bigger percentage, and that will be the maximum percentage error. So the lower percentage error will be 484 minus 462.25 divided by 462.25 multiplied by 100. This will give us 4.71%. Do the same with the upper. So the upper percentage error will be 484 minus 506.25 divided by 506.25 times by 100, which gives us 4.40%. So the maximum percentage error would be the first one, as it's a bigger percentage. So the first one, the lower percentage error, is the maximum percentage error in the estimate. And that is percentage error.